Hello guys, can you see my screen? I just shared.
Yes,
Okay. All right. Sure. Thanks for the confirmation. So once again, good morning to you all. Good morning, good afternoon, or good evening, wherever you are connected. All right. So I'll first go through the Kubernetes. We'll talk about a few things in Kubernetes, and I will try to give as much as information possible over here. And that's the intention of this demo session. All right. Demo session is not to start the course, but is basically to give you the information to clarify your doubts and what is expected from this course. Right. All that we will discuss. Right. Including course contents, how we are going to do, what would be our lab setup, what would be our duration, timing, everything. Right. So before I proceed further, let me introduce. All right. So my name is Prashant. Right. Prashant P. I have around 20 years of experience in IT industry. Uh, Basically, from DevOps and cloud solutioning, it's been 8 years now, and I'm also full-time working for an European customer as a cloud solution architect. Right? Regarding my trainings and freelancing, it's been 5 years now. Can you guys please go on mute? I hear a lot of background noise. Right? So wherever appropriate, you guys can talk to me. Otherwise, just stay in muted so that this session is recorded and we will get the better quality of recording. Thank you. All right. So trainings, it's been 5 years, right? So I do a lot of trainings. Training is basically my passion, right? Though I am working for a European customer, but training is my passion. And out of passion, I do a lot of trainings, right? I do a lot of trainings on Docker, Kubernetes, Red Hat OpenShift, right? Few monitoring tools and automation and all that thing, right? So that's about me. And advantage over here is I'll bring a live example, live use cases of customer projects, production environments, real-time scenarios, right? So I will bring that into the training, and that will basically help, right? Will give you an edge. Another thing is, let's say tomorrow you want to switch the job, or you are looking for a to change your profile and go in DevOps direction, or maybe a Docker and Kubernetes stream, right? And you need initial some handholding session, right, till you settle down, because it would be new profile, new requirement, new project, and you are not yet aligned. So what we do, we also provide a backend support, right? So we charge minimum charge here, weekly basis, weekly this hour, monthly this much hour package, and then we provide even that support also, right? So that you can even take our help, right? So it's not only that our relation is built only for training and then goodbye tata. It's not like that. We build a strong relationship. Being IT professional, we always try to help people, right? And today if you see, like, we are also, Visual Path is also corporate favorite. We give a lot of corporates, they have given, they have made a partner, Visual Path as a partner, because normally you have seen like L&D departments, learning and development departments, right? They are not able to meet all the requirements of trainings. Be- Why? Because there are more than 500 IT courses, right? And it's really difficult for them to find a particular SME or particular domain expert who can lead other people's into a training and train the people so that they can expedite and onboard into their project requirements or a customer facing projects, right? So that's why they deal with the premier partner, like, and Visual Path is one of them. All right, so this is about me. Let's moving. I'll go through this content, but I'll skip this content for a while because I will directly jump to the contents from the certification tracks. So normally this is the logo of Kubernetes, and if you have seen the Kubernetes, basically we have two special tracks. One we called as a CKA. This called as a Certified Kubernetes Administrator. Right. So in this Certified Kubernetes Administration, what we do, it basically covers end to end, how to set up the cluster, what is Kubernetes, how to install Kubernetes, what are various components in Kubernetes as a master node or a working node, how the master node going to maintain and manage all the worker nodes, and how my application will be deployed on the worker nodes, right? And who will help him to do the scale up or providing the resources so that my application should always stay in healthy state, right? And a huge layer of orchestration, which we will talk in detail. So we will do the CK course for you, right? So let me go here in CK, and we have another track which basically we have certified Kubernetes application developer. So when I say application developer, here we focus purely on developer, right? So purely development side. So if anybody comes from a programming background or a development background or a customer building solutions, and he knows to understand that how this technology will help him, right? So while building a solution for a customer, he should think from a development perspective, so that he can develop the solution based on the things in hand, that okay, I have to do the things provided these are the parameters I have to consider, and then he will build a solution, and then we deploy into Kubernetes environment, right? So this is all about the developer perspective, how the solution will be built, right, when the requirements are in hand. So we'll not go there, we will go to 𝐶𝐾𝐴. Okay, so this is official website, right? I'm not saying that we have created. We will follow the official link, right? So we will be not only just doing the training for you guys, but we will also be preparing and training you guys for certification track, right? So that you will be very soon will be certified on 𝐶𝐾𝐴, right? 𝐶𝐾𝐴 price and certification price is not included, but training we will do the all the contents and the track we will follow from the certified Kubernetes, all right, which we call 𝐶𝐾𝐴. So let me give you a quick information here. Right, basically it's a CNCF they are managing, right? So this is the Linux Foundation Institute. They manage the certification, right? All the certification. So I'll give you a few information over here. So this certification price is approximately 400 USD, right? 395 USD, right? Only for exam, right? And you can directly book the exam here, because normally nowadays all the exams we need not to go anywhere. It's all online. So we can register here and we can do that. They also offer a package where you can purchase a package almost adding another $200 on top of it, and they will provide you some course contents also, but they would be just more like a, not like a instructor led, but it would be mostly like a recorded sessions. So they'll give you a huge catalog of recorded videos and all that thing. You can just go learn yourself and then come for exam, right? They do all that thing. But here what we do, this exam fees, right, you will pay, and then we will train you for that, right? And it's an instruction led. That means I will be working with you, and if you have any doubts, any questions, or anything which you're not understanding, I will be there to help you. All right, so that's the advantage over here, and this is the disadvantage over here. Now once you pay this price, right, you once you get certified and all that thing, normally you will also get this logo, right? This wheel, the periphery wheel, right? So this wheel is basically Kubernetes logo, and it will be titled like this: you are certified Kubernetes administrator. And you can put this logo in your CVs also, because now what happens is, even the corporates, right, I'm talking about global recruitment, not only just in India, right? Global recruitment, where people are hiring based on the certified professionals, right? That means they are surely and certain that this guy knows the Kubernetes, right? They need not to put efforts, right? So that way it gives an edge, and Kubernetes skills in the market is on high demand, right? It's really on high demand, so you will definitely get an edge, right? And that's the reason we are not just giving you training, basic training, and just we are done with it. No, we are preparing you for certification, so that you can take advantage from this session, this training, time, money, whatever you are going to invest, you should be take all the advantage, and that's how we are going to build your profile, right? It's not only just to do few training sessions and then we are done with it. It's not like that, right? So in this journey, when you pay this much amount, right, how we are going to do? So basically, let me give you the few things so that you can understand. So this price includes, right, what all it things it includes. So it says the exam mode is online. All right, so exam mode will be online. That means you can book an exam and then you can write the exam. But only thing in the online mode is, right, they will give you some tool, a small utility tool, which you have to run on your laptop, and that laptop, it will collect the capability and configurations from your laptop and see whether your laptop is compatible for that exam. Normally 2 CPU 4 GB RAM is the minimum requirement, right? It not should happen that exams is for 2 hours and your laptop is taking so much time in loading the questions, right? So the navigation and the loading of the exam module should be easy. So they have defined few resources that these are the minimum configuration required on our laptop, right? That's why, right, they'll give you some utility and they will do a compatibility test, right? So that your laptop and your instrument or your device is applicable, right? It meeting the requirement. It should not be like delayed and your laptop is so slow and the question itself is not getting loaded, and right, 2 hours just gone like that, because the clock is ticking, right? On top of the head, the clock is ticking all the time. All right, so it would be online exam. All right, duration of this exam would be 2 hours, right? So duration of this exam would be 2 hours, right? So all Kubernetes exams nowadays, they are 2 hours. Earlier it was 3 hours, right? And it's slightly complex, so they have reduced the complexity and slightly they introduce a little bit ease so that people can qualify and pass the exam. So the duration would be 2 hours, right? Now, when I say online exam, there would be a Kubernetes representative, right, who would be sitting in the opposite side, right, and who would be continuously monitoring you for the next 2 hours, right? Or whenever you write this exam for 2 hours, he would be monitoring you. So your laptop should have a webcam also. If you don't have a inbuilt webcam, no problem, you can connect external webcam also, right? In the market they are available, USB driver based webcam, and you can connect it, and the the instructor would be monitoring you. He would ask you to scan the room, that's so nobody else is sitting in the room, right? And you are writing the exam in a sincere mode, not like somebody is helping you, right? So he will do the scrutining by scanning the whole room, and then once he's satisfied, he will give you thumbs up, and you can he will load the exam, he'll start the exam, and then you can start taking the exam forward, right? In between, like there would be a connection drop or something, some issue has happened, that guy will help you, right? So it's not like once some network drop and the next exam module you are not able to load and you are in trouble, right? So that guy will help you, right? So it would be a professional module. It's not like just go there and write the exam. You would be monitored, right? It would be a virtual exam. Now the certification validity is only for 3 years, right? Why I am saying only for 3 years? Because it is expected that the technology will again change, right? It is not like that today you learn it and forever lifelong it will remain same, right? Nothing remains same in technology forefront, right? Nowadays it's a very fast, right? Every day we are having so many updates, right? Every day we are getting modern technology, modern tools, modern business processes, and we are driving the technology a lot more faster, right? So they are also expected that Kubernetes will also have an advanced modules inbuilt, and you should be get trained on the advanced modules as well. You should not stay with the old modules, right? So you should enhance your Kubernetes knowledge, right, just by preparing with the advanced module. So you should be always in sync up. So it is expected that your certification or the Kubernetes per se would also have an advanced things, and it would not be the same thing as is, right, what we will going to do in today, right, or probably with few months, right, it will again change. So once you are certified, that date, that okay, let's say today is 3rd June 2023, right? So again it will be valid till 5th June 2026, right? And then 27 28, right, it will again change, right? Normally what happens, people get certified and they always upskill. They need not go for certificate. They can already say that okay, I'm certified on this professional and I'm already upskilled, right? That is also in corporate we do like that. It's not like everybody is asking for your proof. Okay, what about, oh, this is expired, what about the proof, right? It's not like that, right? So you can always upskill yourself, right? Normally we do while working, we always enhance our knowledge, right? So we always work on advanced things, right? Not on the legacy system or legacy application patterns, right? So that's the intention, that technology will again change and you should also upskill again, right? So if you want to go for rewrite exam, you can go for rewrite exam, but you are already in that level and you are not going to change your company or anywhere else, right? And you already going up in the ladder in the same organization, you can upskill yourself. No need to go and rewrite the exam. But if your company forces you that okay, your profile we want to shortlist for various project bidding and we want to float it for various global customers, right, they will support you, right? So it is expected that you should do, and that's the reason it is valid for next 3 years. Right now, once you take the subscription by paying this much amount, right, this much amount for exam, basically exam, when you purchase the exam, you get a 1 year subscription. What do you mean by subscription? That means you can write this exam anywhere between the date you purchase till 12 months. That means it is valid for 1 year, right? Only for 1 year. Don't think that it is valid for 3 years, right? No, the certificate validity is for 3 years, but the exam you have to take within a year only, right? So if you purchase it today, right, June 3rd, then next year, right, 2024 June 2nd, you should finish your exam, right? So you will get basically a decent amount of time. It's almost around 12 months. So you will be writing the exams here. Now what happens is you are giving so much money, right, almost around 400 USD, right? But there are some discounts going on and all that thing. I will give you the coupon codes and all that, and you will get slightly 15 to 20% less, right? So that I will help you, right? Don't worry about it. So we normally at Visualpath, we help all our candidates, and same thing, we'll pass the benefit to you guys also. Now what happens is one retake is free here, right? One retake is free, right? What is one retake? One retake means basically it's 1+1 offer. All right. If you pass the exam in the first go itself, right, in the first attempt, right, when you write the exam and you're passed, right? So basically 65% is minimum score, and you get above 65 and you pass the exam, then forget about the second chance because you are already certified. You need not to rewrite the exam, right? But in case, right, God forbid, right, in case, right, I'm just saying, right, right. Usually we never go for second chance, but in case we are busy and sometimes, right, we we didn't get the passing marks and we score slightly below, right, and we didn't pass the exam. So in that scenario, what happens is one retake is free. That means you need not to pay again, right? You can even write the, because it's a 1+1 already included, it's a bundle package, right? It's already included. So what you can do is, right, you can book the exam, rewrite the exam again, and they will see, okay, one attempt you have already done, and it's very much in the window of 1 year, right? Within 1 year you can even take the retake exam also. And normally in the second attempt people pass, right? So people pass the exam in the second retake. So it's basically 1+1 offer. So one retake is free here, right? So today you take this exam, let's say June, and we finish the course in the first week of July, right? And if you want to write the exam somewhere in the end of July or first week of August, no problem. Just go and book the exam and write it, right? And let's say somehow we couldn't pass the exam, right? You can rebook the exam maybe 2 months later, 3 months later, 6 months later, but it should be less than 1 year because your subscription, exam subscription, will expire within 12 months. So considering those window, and the portal and everything will be registered, you can go check your expiry date and all that thing, your previous exam, other thing, all that thing you can check online, right? So you will have a huge dashboard and your account will be created with all these details. All right. So that way they will be very transparent and you will take the benefit of retake, right? Certificate normally it will be issued into PDF, and a digital badge will be issued. Basically they'll send it everything on your email ID. That badge you can take it and put it a logo on your CV, right? Maybe header, footer, wherever you want to put that logo in your CV and float your CV, right? LinkedIn, Naukri, wherever, whichever profile, Indeed, or wherever you see a global job portal, just float your CV with that logo, right? So that people will hire you, because now corporate people, they do all the recruitments based on certified professionals. So you will also be listed as a certified professional. So that's the advantage over here. And if somebody wants to do a validation and verification on your certificate, that are you really certified or not, I want to verify it, right? You can pass this information to your HR or recruitment team or whoever, right? Maybe sometime customer also, they want to be very keen to verify the credentials, they can also verify, right? So you will give a certificate. Every certificate has a number, okay? That would be your personal number, and your certificate is mapped to that ID. And if somebody goes to the certificate ID or a portal, they can just enter your ID and they'll get your name, details, date, version, everything, they'll get it. All right. So this will be PDF and this will be mailed onto your email. Kubernetes version. So basically this is the version that currently they are taking all exams on this version, 1127 version. All right. So this is a version of Kubernetes, and it's purely a performance based exam. What do you mean by performance based? Right. So there are two ways. One is objective. Right. All right. One is objective. Objective means they will give you four question, right? A choice of four question, and you have to pick up the appropriate correct question out of the four. So out of the four, so that means it's an objective question, objective based. So four question will be there, and best of the best, you have to choose, and you have to take the exam in that way. So it is not an object; it is a performance based. That means all question will be on scenario based. They'll give you some scenario that this pod is not running, right? What is wrong? Please go and correct it. So they will give you a lab, the cluster and everything is created, and in that scenario this dedicated scenario will be created where this pod is not running. Pod means the application in a container mode is not running, right? So you have to go check the log and see how you can correct it and make it, bring it to a runnable mode, right? It should be up and running, right? That's the target, right? So that's how all questions. So in 2 hours basically there will be 17 questions, 17 to 18 question will be there. Average 17 question they ask, but one question is simple, then they will ask another. So 17 to 18 question will be asked in 2 hours. So approximately 10 minutes per question, 10 to 11 minutes you have to finish each question, right? So that you can attempt all the 17 questions, right? So that is the thing, but it would be purely performance based. That means they'll ask you scenario based, right? So there'll be some problem in particular thing and you have to fix it, right? you have to fix it. So you have to do everything hands on the lab. So in the exam, there will be 3 links. One link will be question, and below that there is the link to go to the lab. Right? Click on the link, and it's everything is online. You need not to install anything on your laptop. Right? Go to the link, and then on the lab, the same question will be there. You have to just tweak it and fix the thing so that the question or the pod or whatever the question is scenario based, that scenario you are through with it. Once you are through, right, and that is how you will navigate to all the 17 question and you are done with it, right? So every question will be performance based. Some question will be interconnected also. All right, they'll ask you to create the storage, and the second question they'll say, okay, I want to read the data from the previous storage which you have already configured, right? And once they say, okay, now this data is there, now I want to do the scalability, right? So auto scaling and all that thing. So it would be, sometimes the question will also be interlinked, right? So go in a right flow, and then you should understand all the thing. But if you practice and if you do this training thoroughly, you will pass the exam. It's not that big deal, right? Many people are certified, right, who are trained by us, right? Now here, one more advantage here is exam simulator. All right. Exam simulator is what? What do you mean by simulator? That means they have a simulated lab. That means they have a prototype lab environment is already created before you go for exam. And that would be first time you are experiencing, right? In 2 hours, half 30, 40 minutes is already gone, right? To get familiar with the lab setup, to get familiar how to do this question, where to go it, how to see the output, where are the log files, right? You will be confused. So what they have done is they will give you exam simulator in hand as soon as you purchase this exam, right? And this simulator is valid for 12 months, so anytime you can take up, right? It's free of cost. And they have a prototype, right? The way you are going to write an exam, the same way they have simulated in a separate environment. So basically there are two simulators, simulator 1 and simulator 2, right? And each simulator has around approximately 25 to 30 questions. So approximately if I combine simulator 1 and simulator 2, around 50 to 60 questions are already there with you. You can practice, and all are performance based. So basically they are also preparing by giving you platform, right? They are giving a platform where you can go and practice, right? And once you practice, I'm damn sure if you do the simulator seriously, right, then you will certainly pass the exam, right, in first go itself, right? Do both the simulators, simulator 1 and simulator 2, and you are sure you will pass this exam. I am sure you are able to see the fonts. All right, so it's here, right? I just slightly increase the font. Right, so this exam simulator, we normally we say killer 1 and killer 2, right? Don't get be scared by the names, right? All the names are like that, right? Even Python, if you go to Python module, all the modules are like that, right? Anaconda, Python, this, that, right? So don't get scared. So killer 1 and killer 2 are two simulator exams, and it's a prototype lab, right? Clock will be ticking for 2 hours, question will be loaded just like an exams. You will see, right? First question, do the exam, then next clock is ticking, and how much time you are taking to finish the exam, right? Fail and part doesn't matter, right? Though they will give you result and everything, but doesn't matter. Go and again practice, right? First, I'm very sure that first time when you do the simulator exam, right, it will take hell lot of time, right? You may not be able to complete all that in 2 hours. Doesn't matter, right? Ultimate goal is we should thoroughly get into that mode, exam mode, and practice ourselves and prepare ourselves. Once you're prepared, second time you when attempt it, you will finish it within that time window, right? And third time when you do, you are thorough with it, right? So it needs a time only, right? So basically it's time because it's a performance based. And how will you do performance based? Only by investing time. All right, so this is like that. Okay, so we were here, right? So now let me talk about the contents, right? As I said, we will be doing all this course, right, from the certification track, and very much we are aligned with it, what we are saying here, right? So this is your domain and competencies which they are looking. So basically, if you see here, this is the weightage it has been given, right? Let me slightly expand it. All right, this is the weightage it has given, right? And if you see here, it shows some logo that you have some shopping coupons is available and all that. So don't worry about it. I'll share all this information little later, not needed for this session, right? It's something when we prepare for the exams. Normally, when after finish of the course, that time we'll talk and I'll share all that thing. So don't worry about it. So if you see here, basically they have around 5 modules, right? And they have given the weightage in terms of percentage. So storage, there would be 10%. That means there will be short question from the storage also, right? At least one or two question will be from here, right? So storage 10%. What all things are there in the storage, right? Let me expand it. So here, right, and don't worry about it, right, leave it to me, right, leave it to us, and we will do it for you, right? So this is a part of the course. So here, understand the storage classes, right? What are the storage classes, right? So dynamic, static, right, all that thing, right? On premises, cloud based, right, third party, all that thing we'll see. And persistent volume. Persistent volume is basically the name in Kubernetes storage. If you know Docker, we say volumes, but in Kubernetes we say persistent volume, right? So don't worry about the terminologies. It is expected when we learn new tool or new technology, the new terminology will also come into the forefront, and we will be learning those terms also. So the persistent means permanent storage, right? Permanent storage, and Kubernetes we say persistent volume. So here first we will understand what are the various nuances, semantics, and nuances around it, and basically we'll start trying to build our own storage in Kubernetes, right? Kubernetes and inbuilt modules we will also spin up, and we'll start trying to configure our storage for our application or our production environment, right? All that we will do it here. And then understand volume mode. There are various modes are nothing but access modes, right? And then a reclaim mode. So here we can even control that people can get only read only access. If my data is very critical and testing team, they want to take a customer data and they want to test the functionality of my solution which we are building for a customer, right? So nobody should change the data, right? So we will give a read only access, so people can come take the data and test it, right? So I can set a read only access, right? Or if we are building a new thing and we are adding a testing capability itself for a customer, then I will give a read and write access, so that people can take read it and they can even enhance it further for their testing purpose. So there are many multiple use cases, right? And not only just one. So 1 2 3 4 5 like that, and we can give read and write access, right? So there are various access control, right? So we can give read write access and all that thing. So everything we can enable while configuring the things. And then we can enforce some policies also, right? Every corporate, right, every corporate follows some standards, and nowadays every standard is followed or driven by a policy. When I say policy, means basically a standard and a guideline, right? So that we are very much aligned to the policies, right? So policy will also bring some kind of restriction, right? Maybe naming standard policies, or a configuration, or a storage capacity, or a configuration, right? So all that we will understand it here. And then understand persistent volume and claims primitive. Normally claim means your application how it's going to use. So basically we follow a claim study. Claim is what? Basically how to claim, raise a claim and start using it. So basically it's a request, right? So if I want to use the storage of Kubernetes, right, I will first have to raise a request that, hey, my application is front end and I need a backend, and for that my data will be flowing here and there, so I need a storage. So I can even set the claims, right? Claim is nothing but a request. I can issue a request. My application will automatically request the storage and it will get the access, right? So we have an automated provision where we say persistent volume, we say PV. PV is in short, right? Persistent volume. And here we say PVC, persistent volume claim. All right, and there are various primitives around it that I will talk in detail when we take all the use cases of the storage. So PV and PVC. PV we have to create as a physical storage, and PVC is how to use it, right? That's the difference between the two, right? And anyhow, we will be deep dive with all these things, so don't worry about it. And then know how, right? Know how to configure application with persistence. So when you onboard the application, how your application going to use this storage, right? Because today you are building some query, right, in database, right? And then tomorrow again you want to have some more thing, right? Maybe a few other queries to pull the data from various sources. One source is from here, another source from another, and you are building, right? Your data is flowing from various sources. So all these sources, right? Who will take care of it? Kubernetes will take care of it. So here we will see how the know-how to configure your application on top of the storage, right? So your application will always fetch the data from your storage itself. It should not go outside the Kubernetes. Because of the security reason, it has to be part of the Kubernetes, and that is how we will build all the knowledge around storage over here. All right. Same way, we have troubleshooting. Troubleshooting is the highest percentage over here, 30%, because it's a performance based and it's expected that you should do a troubleshooting. So when we learn this course, right, and it's basically purely hands-on course. So we will cover all the use cases, right? This is not working, where to look it and how to fix it, right? All the trade and tactics, right, we will learn while building the knowledge for you, right? Or when we have the training, each and every module we will have trade and trade tactics to bring the applications, right, and purely hands-on thing. So we'll cover up all the use cases over here, and that is how we'll be building our huge landscape of troubleshooting, right? So we should know what are the troubleshooting approach, right? What are the troubleshooting practices, right? What are the troubleshooting tactics, right? All that we would learn over here. So let me expand this guy also. So here, to evaluate cluster and node logging, right? Nodes are nothing but machines. So Kubernetes cannot be installed on a single machine. Why single machine? If this is my production environment and all the applications are loading on just a single production environment or a single production machine, right? What happens if this machine has some problem and goes down? Let's say my OS itself is crashed, right? Or it is out of the networking is crashed, right? Or while updating the patch, right, something has, some complexity has occurred and the environment has gone down. So we cannot always rely on a single node machine. It should always a multiple machine. So if my one machine goes wrong, right, we should not have that feeling that my whole environment is down. No, we cannot rely on a single node. So for that, we always have a cluster based environment. What do you mean by cluster? Right, and I will be talking all for all these terms to just bring a lot more ease and comfort, right, but little later. So cluster is nothing but collection of machines, right? Cluster is nothing but a collection of machines or a group of machines, right? So Kubernetes always be configured on a group of machines. If one machine is down, right, my environment should not go down. It should still be up and running, and I get a breathing space to go and look at that machine which is down. All right, so basically it's a thing. So here we will see, right, how to evaluate cluster for Kubernetes and the node logging and all that thing, right? Node logging means each machine we have a log and all that thing. If how to join into the cluster or some issues with the node, right? Then we have a logging mechanism. So here we will practice all that thing and then understand how to monitor the application, right? So monitoring layer was right in traditionally, if I look at anything, we have been talking innovation, 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 but I never saw the innovation, right? Right, frankly speaking, last 10 decades, right, right, we never saw the innovation. We are only talking that we'll bring innovation, innovation, but it's just a term base we are talking, but we practically at a ground level, right, that innovation was missing. But since this tool has arrived in the market, Docker, Kubernetes, right, infrastructure as a code, right, so monitoring is the essential element, right? We will monitor all the time our environment. I will monitor my application. I will monitor the health check of my application, whether my application is scaling, whether my application is able to process the request, right? It is accepting the request, right? So we take the monitoring as an essential component, and Kubernetes has an inbuilt monitoring capabilities. All right. So here we will see, right, understand how the application is monitored, right? So if let's say in middle of night I'm there in the office, right, and the application is wrong, then I can just go and look at it, right? But imagine nobody is there in the office. We work in normal shift, right? Nobody's there. Right? We work 9 to 6, and after 6, nobody's there in the office. And middle of night, 1 a.m., some issue has occurred, and my application is failed. So what is the traditional approach? Next day morning, when I go to office at 9 o'clock, I will walk down to data center, look at my data center server. That okay, this application went down at 1 a.m. and I'm in the office at 9 a.m. That means the productivity of 8 hours is already lost. All right, then I'll look at it, open the log file, try to fix it, and around 10 o'clock the application is again up and running. That means 8 to 9 hours already lost. Kubernetes doesn't wait for that long, right? Because of monitoring capabilities, it has auto healing capability, and it will try to bring my application right immediately. So let's say at 1 a.m. the application is down, one right 101. That means 1 a.m. and 1 minute the application will be up and running. So less than a minute it takes, and the application will be up and running. Why? Because of inbuilt monitoring capabilities. So here we will see how the application will be monitored, right, at a Kubernetes end, and what Kubernetes tries to do is not only just monitor and raise a flag, red flag, that okay, this application has gone down, raise a red flag. No, it's not like that. It will also do auto healing. So that means the next course of action will also be done by this guy. All right, so here we will see that, and then manage container standard output and standard error log and all that thing which we will see. Right, container means Kubernetes application running in a container mode, and here in our course also we'll be building the knowledge around container, which is through the Docker course. Troubleshooting application failure, when the application fail, right, because of so and so issues, might be the scalability issues or application OS connectivity or network connectivity, or application itself is not coming up because of the coding error or the integration error, or might be some enterprise architect level error, right? So whatever is there, we will again try to fix it over here. So there are various things how to bring the application back, right? Because we already have a monitoring, right? That means the the diagnosis tools are already available, right? So here we will bring the application into a success mode from failure. and then troubleshoot cluster component failure, right? If any cluster component, Kubernetes uses inbuilt component, right, for monitoring. Kubernetes uses inbuilt component for scalability. Kubernetes uses inbuilt component for networking, because multiple machines. So one machine talk to another machine can talk to another machine, right? So networking also, underneath networking also, all the time it should be up and running. So all that thing, if inbuilt components are not working, Kubernetes uses its inbuilt database also, right? All cluster info will be stored in that database, right? So if the database is not up and running, or there's some issue at the database side, right, who will give me the information? Because the powerhouse, the information powerhouse is database, right? So here we will see all that thing, that all the components should always stay in healthy state. So basically Kubernetes has a one discovery service, and that service every 20 minutes go and check the health of each and every component, right? How it will do, probably we will discuss, right? So when we start the course, right? So this will, we will discuss. Normally in my first and second session I discuss in detail. Then networking essentially, right? So don't be scared here. Networking, when I say, people think that okay, network itself is a different domain, it's a different layer, right? And it's all together. Network is a very vast, it's not easy. Network is very, very vast, and that's the reason we have a different set of people who work and support on day-to-day basis, right? IT support people, network support people, right? IT infra people, right? Normally they take care of networking, but here Kubernetes has ease of a life. Even networking in a fingertips, I can lay down any kind of network, right? Any kind of networking. So when I set up the cluster, there are multiple machines. How would I connect to each machine, right? So that Kubernetes go and start managing those machines automatically, right? Because of the networking, right? And here, because of the Kubernetes simplicity, we will we will dwell with all this networking and understand all the semantics, all the nuances. It's a lot more easy, right? So don't worry about it. We already have a few sessions here, and we'll do both in Docker as well as in Kubernetes. So here we will deep dive here. All right. So here this is very essential component, right? In terms of day-to-day life, right? When you jump onto Kubernetes and start taking up a role or a project support, right? This would very essential. From exam point of also, this is have a highest weightage of 30%, and then workload and scheduling around 15%, right? So here, right, understand deployment, how you will deploy your application, right? So there is a deployment strategy we can deploy, and how to perform rolling updates and rollbacks, right? So here, how we will upgrade the application. Let's say I deployed one Nginx server or Apache server or a database application, right? But right, we are following agile project methodology, right? So every project is driven through agile. When I say agile means, we have a very short span of time. That means in a month we will be having sprint by sprint module, right? Sprint by sprint module means each sprint is of, right, of duration of 2 to 3 weeks only. So that means in a month we will have two sprint cycle, right? And my development team is also agile, my testing team is also agile, my network support team is also agile, and my production deployment team is also agile, right? That means everybody is aligned to these sprint cycles, right? They have their own priorities driven by the product management team or a project management team, right? And these guys, they will be the stakeholders, and they will be saying that okay, this is what we want to deliver end of the sprint, or in this month these are the milestones to be delivered. So here, right, here we will see as and when my development team is coming with the next version of the application, right? Because they have added one more feature and the application version. Let's say we were using Nginx 1.0, and now Nginx 2.0 is launched, and it is tested by the testing team, right? They certified that okay, no more bugs are there, and is a good candidate to be deployed in a pre-production environment. And then again we'll do a UAT with the customer, and we take the sign off, and then we will roll it off in a production environment. And then that is how we push the code from development to testing to production, so pre-production, and finally to production, right? So here, right, so how we will do rolling updates. So here Kubernetes has its own inbuilt methodology or a strategy. Using that methodology, we will push the application to an auto upgrade mode, right? But it will be driven by us, right? We will push it, and Kubernetes will automatically go and sync up. If my application is running on machine 1, machine 2, machine 3, machine 4, will not do manually, it will be automatically taken care by Kubernetes. And if I upgraded the application, right, from version 1.0 to 2.0, and I feel that after 1 hour the new upgrade is creating some problem in the production environment, then immediately I can roll it back, right? I can immediately, what I can do, I can roll back, right? So we can do rollback or upgrades, right, automatically on the fly, on the go. Then there's no need to bring the production environment down. Traditionally we used to do down, right? If you see banking application, right, we used to get a message on mobile phone that the so and so application or the HDFC banking application won't be available from 2 a.m. to 4 a.m., right? Because they do all these maintenance, upgrades, patching, all during that maintenance window. But in Kubernetes, we never bring our environment down. Everything will be on the fly, on the go. So here we will deep dive and understand those processes. Then we have config map and secrets to configure the application. Config map are nothing but configurations, right? During runtime, every application needs a runtime environment. And for runtime, I should tell my application that, okay, go and pick up the DLLs from that folder, go and pick up the executables from that folder, go and pick up the dependency from that thing, right? That is how we set the environment variables, right? We set the path, right? And we load the module will be loaded, right, by reading all the environment variables, because they will be supporting and they will be navigating. Okay, load the DLS from this folder, dependency from this folder. Here we don't do all that manual thing, it is an automated thing. But Kubernetes has a different special way to handle environment variables, right? And if my environment variable has a sensitive information, for example, I need a login credential for a database application, front end is fine, but front end is dependent on backend, and backend we cannot just open the connection just like that. We need a credential, right? Now those credential I cannot put it just like a text file, right? Anybody can open my text file and see, oh, this is the username and this is the password this guy is using, let me steal it, right? If he will steal my credential, then it would be a disaster. So Kubernetes, what it does encryption decryption here, and that is how we say secrets here. So Kubernetes has an inbuilt encryption decryption capability also, and here we will do all that thing, right? So it's a part of applications configurations, right? During runtime, how my application should be run, right? So we'll use all the environment variable tactics, right? All how to handle the credential if my application needs some credential to log in during runtime, right? Front end wants to connect to backend, but we have passed some credentials, then only it will log in, right? Otherwise my database will be attacked by the intruders. Anybody can attack my database. So here we'll handle with a slightly sensitive, right, bringing encryption and decryption technology. All right, so this is inbuilt again in Kubernetes. How to scale the application? Scalability is traditionally a one of the biggest challenge, right? The performance testing we do, but still application fails, right? And we have seen in the world many use cases, right? Pokemon, when they launched the first gaming application, it was so popular, but within a week the application, right, they were not able to support all the customers, because they tested this application only with the 50,000 users, and because of word of mouth publicity, right, there is a huge customer base they created, and everybody was trying to download and start playing the game, and the production environment was not supporting all the requests, and it used to get stuck, right? And they were getting a bad mouth, right? They're getting a very bad mouthing within a week itself, right? So imagine if you are launching a product with a huge investment, and within a week, right, you end up at a failure, right? It would be a biggest disaster, right? So here we see how my application will scale up as and when my traffic increases, right, or my subscription increases, right? Netflix, right, today we are using, whole world is using. When the Netflix was initially launched, right, the guys who were the brain behind the Netflix, they thought that, okay, if we roll out this application only across US states, they are the happy go guys, right? They thought that if we roll out, if we are succeeded in just rolling out in the US states itself, and they are the happy go guys, because they thought that, okay, we'll have a huge customer base, and we'll start making money, and we will be happy go guys, right? And what happened is, right, because Netflix is basically a online streaming, I need not to just buy a ticket and go to a particular PVR or Inox, and only during that time, that show I have to be there, then they will play the movie for me, and I will just go and see the movie. It's not like that. Anywhere, wherever, right, I can, whether I'm in the aeroplane or driving a car or in the running train or at home, right, wherever we can play it, right? So it was so popular, Netflix, when it came online streaming platform, so popular. But they also, right, within a first month itself, right, they start getting hit, right, because of the scalability, right? There's a huge traffic coming onto their server, and they are not able to serve all the requests, right? And the people start getting latency. Ultimately, more and more flooded of traffic is coming, and the whole environment went down, right? So these guys, right, literally struggling, but they heard the story of Kubernetes, that Kubernetes basically have auto scaling platform, right? And they came to Kubernetes, and once the application deployed in Kubernetes, and rest is the history. Right, so there are many use cases. We will talk more in detail. Right, so scalability is again here, and Kubernetes handle the scale. So there are many use cases here. Right, even the auto scaling, automatic scaling, and everything we will talk about here. Then understand primitive how to create a robust self-healing. Right, I was talking about at monitoring. I was talking about healing, self-healing. So Kubernetes has a self-healing capability. As I said, middle of night my application is crashed, nobody's there in the office, I'll go to office next day morning. Right, will my environment be down till I go to office and look at it? Right, so Kubernetes doesn't wait that long. It has a auto healing and self-healing capability. It will heal my application automatically, and it will redeploy the application. The whole environment will be redeployed, right, as a fresh, and the application will start running within few seconds. Right, so this is the again one of the core feature of Kubernetes, which we will deep dive. Right, guys, am I too fast? Right, you can stop me, right? Because these are just the course contents. We are not doing anything here, just the content. So I'm just going in my own pace and momentum. Are you able to hear me, guys, or I'm talking to myself only?
No, no, we are able to hear. It is clear.
Good, good. Thank you, thank you. All right, then resource limits and pod scheduling, right? So now I can even declare the resources, what my application needs. Let's say I have a database application which is slightly critical. So when I deploy the application, I should provide a required resources, right? Let's say this database application is slightly critical and needs 4 CPU and 16 GB RAM, right? How do I just go and declare that this application needs this kind of resources? So here, because of the resource limits, right, I can set all my limits while deploying the application itself. I can declare that, okay, this application needs so and so resources, and Kubernetes will dedicatedly assign the resource, and it will always measure that this application should not get less than resource but more, right, because of the scalability feature. And that is how it will do the alignment with scheduling, where my application should go, which machine 1 is already having 80% load, machine 2 is having 60% load, machine 3 is having 20% load, and machine 4 is having 10% load. So it will internally do a polling and see, okay, my pod should go to where. Pod is nothing but your application running in container. Where it should go to machine 4, because that machine can give me resources. That machine 1, it should not go where, because it's already above 80%, right? Previously application might have deployed, and because of that it is already has gone to 80%, right? If the machine is overly utilized at 80%, right, and I need more resources, right, so it is not an ideal situation to go to 1, right, or go to 2, so it will go to 4. Who will decide? Kubernetes will internally decide, right? So here we will see all that thing. Awareness of manifest management and common templating tools. So Kubernetes has inbuilt templating. Basically, it's a templating only, right? No coding at all. When I say templates, means it's just a key value pair, right? Let's say IP address is the key, and IP address 172.10.20.30 is IP address of my application, right? So only key value pair. I need not to do any program. Not even a single line of coding is needed, right? Just a straightforward thing, right? Same way, port number, right? So port number is the key, and the value could be 8080. All right, so like that all the will be done in a key value pair, and there are inbuilt manifest files which we do as a YAML templates. YAML is yet another programming language. There is one session on whole session on that, and we will do it both in Docker, Kubernetes, or all modern tools nowadays. We use only templatized thing only, right? That is standard YAML. YAML, they are developed in Go language and all that, which I'll talk little later. I don't want to confuse and bring too many things here. So inbuilt tools, and there are many things, tools or inbuilt YAML validator. We can validate the coding if something goes wrong and I'm not able to deploy. How to validate? There are so many things which we can do, right? So it's a bit handy. It's just an awareness kind of thing. So they say awareness, and we'll also bring more awareness over here. And then cluster architecture and installation. This I have a huge weightage, 25%. That is the reason I given more importance to this thing. So here we'll see how to create our own cluster. Right? We are not going to use any ready-made cluster from Azure Cloud or Google Cloud or AWS or Oracle, IBM. No, we will set up our own cluster, right? And that cluster can be, we can put that cluster in any environment, maybe on-premise or on cloud or any environment. So this would be a universal installer, right? So once you know the techniques, then it would be very easy for you. Tomorrow you can set up that cluster in any environment, right? So here also we'll do that thing. And Kubernetes also in the exam, they'll have a 25% weightage to set up the cluster itself, right? So to manage the role-based access, right? So here we come with RBAC. RBAC means there are developer, there are tester, there are network support team, there are production, there are application developers, right? And the customer. right? I cannot give a root access or admin access to everyone that go and deploy application, go and remove application, go and again redeploy application, go and delete it, go and reconfigure. No. So we can define some access control, right? Developer needs what access, right? They can create pod, they can see log file, that's it. They cannot disturb my storage, right? So likewise, tester doesn't need any access. There no write access, only read only. They will just read the things, get the things, and they will do the testing. That's it. Network support guys, they need some read and write access. So I can control here, right? Who will be having what kind of access, right? Everybody cannot have admin access, or we cannot have a same access for everyone. Otherwise, it will be very difficult to track, right? So here we can define access control model in Kubernetes, which we say RBAC, role-based access. And then Kubernetes install basic cluster. Then here we'll talk how to install the cluster. Basically, first session will be a little bit theoretical. Second session, I'll start setting up the cluster, right? So I'll pick up multiple machines, then we'll build the networking between the machine, then we will deploy start components of Kubernetes, right? One by one, master node component, worker node components, and we will set up whole cluster, and everything will be manually. We will do from our own bare hands. We will not take any inbuilt things, right? Everything will be, we will do it. So here we'll do the installation of Kubernetes cluster as a basic infrastructure which is needed. So we'll do it here. And then manage high availability. So high availability is also another key feature. If my environment goes down, right, how I can ensure that my environment will be highly available in the event of disaster, in the event of failure, in the event of any uncertainty, right? So all that will be, all use cases we would be handling over here. So there are various techniques, and we will bring, right, multiple things here, right? Parallel cluster also, and they both the cluster will be in sync up. If this guys goes down, other guys will be up, right? Normally we used to have active and passive, right? One database active, and the passive database, which this guy will always update the another database. So my active data goes down, the passive database will come into the picture, right? So we make that kind of arrangement for disaster recovery. But here in Kubernetes, we don't say disaster recovery, we say by another term, high availability. How my environment will be highly available in the event of disaster, right? So here we'll understand that part. Then provide underlying infrastructure to deploy Kubernetes cluster, right? And then what are the infrastructure, right, needed for deploying Kubernetes, right, as a whole cluster, a whole infrastructure. So here we'll talk about the infrastructure. So don't worry about it. How many CPU, memory, machine configuration, network capabilities, what tools are needed, what components are needed, how to configure it, and ultimately how to set up a whole environment, whole landscape of Kubernetes. Here we'll set up the whole cluster thing. So this is about infrastructure side. We'll talk about more in detail. Perform version upgrade on Kubernetes cluster using 𝐾𝐶. So 𝐾𝐶 is basically a Kubernetes admin console, right? So there are many console in Kubernetes. One is a normal Kubernetes CLI kubectl, right, which is Kubernetes command line, and we do day-to-day operation using kubectl. But for admin thing, when we set up the Kubernetes cluster, right, there are so many things, right? We want to deploy the certificates, we want to deploy the networking components. All right, my master node wants to control all the worker nodes. How? Right? So there is a kubeadm. It's basically admin console, and through the admin console, we do all administrative activities while setting up the cluster itself. Right? So here we will do all that thing while setting the cluster using the kubeadm. Kubeadm is the admin console, and that will bring ease. Basically, it will help us to set up the cluster. In short. Then implement etc backup, right? Etc is Kubernetes database name, right? This etc is Kubernetes inbuilt database. I will not bring any database from outside or a third party database we will configure. No, it's inbuilt, right? It's already embedded, right? So we will just start using this inbuilt database. And how to take the backup, because this is the powerhouse. All cluster wide configurations, right, all info will be stored in this database. So this database should always be up and running. If the database goes down, who will provide the information, who will provide me the IP address of the machine 1 or machine 2 or machine 3, right? Because this database will have all the details of all the machines. So here we will ensure that we should take a backup and restore process in place. In case of event of failure, my database should can be spin up faster. So here we will see that, right? And ultimately, we have one more last section called services and networking, right? I'm sure I'm taking more time, but that's fine, right? First time we need to give all this information. So services and networking, here we'll talk, services means microservices. All right. In Docker also, we have a topic on microservice, how to build the service, all that thing. I will, right? We have a separate module and separate project use cases and all that thing, we will do microservice also. We'll deep dive. Kubernetes also will explore the services and networking. So network configuration on the cluster, because without that, how my machines will work, how Kubernetes will talk to other machines. So we'll bring the networking capabilities over here, and don't worry about it. We'll deep dive it. Connectivity between the pods, right? My pod is having multiple, right? One is front end, right? One is back end, right? How they will talk, right? Multiple. So here we will see how the connectivity can be established so that my front end can talk to back end, or even middle tier also if I want to introduce, right? Because it's a three layer architecture, right? So three layer architecture, how each each component can talk to another, right? Front end can talk to middle tier can talk to back end, all that thing, right? Payment gateway and all that thing, right? If we are having that kind of scenario, we can talk about here. Then understand cluster IP. These are the services, right? Cluster IP service, node port service, right? And load balancer service. These are basically microservices, and they will do all the inbuilt capabilities. So when you expose your application to outside world, basically we expose through these services. And these are the service. There is a different purpose of the service. Cluster IP service is called an internal service only. It is the internal service of Kubernetes, which will do all the internal operations of Kubernetes. Node port is basically the external service. It will handle all the external traffic. When the traffic is coming and hitting my application which are running inside the pod, who will handle? This guy will handle and provide access. Load balancer on top of it, balance, right? It will do load balancing, right? How much traffic is coming? Flooded or traffic is coming should not hit my infrastructure just like that and bring all the environment down, right? So load balancer will handle the traffic, and the load balancer will start sending the traffic. It will route the traffic from there. So it will be load balanced. So every machine will be having, right, breathe properly and always stay in a healthy state. For that, we need a load balancer. So we'll talk about it. And then know how about ingress controller, right? Ingress controller is basically where we can even measure the traffic and route the traffic, and it's completely a whole landscape where we can onboard the application. For example, to bring the things a lot more easier, let's say we have a Amazon shopping portal. Amazon is selling everything from needle to aeroplane, right? What not? They are selling each and everything, right? So if I'm looking for a particular thing and unnecessary, I'm looking for, let's say, for a mobile phone, right? I want to purchase an iPhone, right? So if I go to a men's section or a women's section and say, hey, do you have this mobile? Hey, do you have this mobile? Do you have this mobile? Do you have this mobile? And I'll create unnecessary traffic, right? I will going from pillar to post and looking for my thing, that where it is available in Amazon portal. Go here, there, go here, and I'm creating unnecessary traffic. It is not needed, right? My application should be built in a logical format, right? It should handle the traffic, right? It should not just flood of traffic introduced and then it is spinning up internally and creating traffic. No. What we can do, so first I will categorize it: men's section, women's section, kids section, mobile section, furniture section, grocery section, retail section, mobile section, laptop section, right? So I've created a compartments, right? My application designed in a compartment. Now when the customers, when I go and do for a shopping, okay, I want to do shopping, I want to buy some trouser, where I will go? On men's section. So I will not disturb the other things. I'll not go to women's section, kids section, laptop section, furniture section. No, no, not needed. I'll go to men's section and clothing. I'll go to clothing and see what I want: shirt, right, t-shirt, or a trouser. I'll go to trouser section. So that means I am routing the traffic. All right, I am routing the traffic where to go for this particular thing. Okay, go there. So I am not creating a flooded of traffic, right? So all these are tactics which are needed when we build the solution. Here we will see, right, the ingress controllers and all that they will control. All right, so inbuilt traffic will be controlled by the thing. And then know how about the pod called DNS. DNS means, right, we cannot remember all the time IP addresses and all that thing, right? If I we are 10 friends, and if we have 10 mobile phones, and if you tell me, okay, here are the numbers, just remember, I'll forget it. But if you ask me to remember by names, right, Sunil, Amit, Rahul, Shrikant, right, it will be very easy to remember, right? So Francis Xavier, right? So we can remember. But if you ask me to remember the number, I will forget it, right? So DNS is also like that. URL, right? Customer who wants to purchase the thing, Amazon, I know the name. Flipkart, I know the name. But if I give you an IP address, right, you will mess up the things, right? So DNS will basically, it's a domain name resolution, right? So it will automatically translate your domain name into an IP address in the background, right? So here we will see all that. Basically, it's an add-on in Kubernetes, right? So, but only from know-how perspective and how to configure, we should know. and then choose appropriate container network interface and plugins and all that thing, right? Many applications we need advanced plugin. If you know Jenkins, right? Jenkins purely running on plugins, right? If you have Java application, go with Maven plugins. If you have a .NET application, go with .NET plugins or Visual Studio plugin, right? Or if you have some Python, then go with Python plugin, right? So every application has been plugin. Plugin is nothing but a runnable configuration, inbuilt configuration through which we can have the application can be configured with lot more ease. All right. So here we will see, and that is how we are going to do this course as a CKA. And these are the things which we'll do. We'll deep dive, and we will be training you following the certification track. And we'll finish you the course, and at the end of the course, you are covering. You are prepared for certifications, right? So that's the thing which we are giving a value add here, that we are not just going and learning the basic things in Kubernetes, but all the things which makes you as a certified professional in that particular technology. Which technology? Kubernetes. All right. So it'll be end of the day, the value add is you will become a certified professional. All right. So same way, we'll let me go quickly through the Kubernetes Docker also, right? Docker course, right? So we follow here DCA certificate. Right here also we follow which called Docker Certified Associate. So I follow certification track. So basically it's a corporate template which I route, right? So that is what I have shared, but that's fine. So here Docker introduction. So Docker Linux container technology, right? So how Docker was invented, right? What all the thought process behind it, and how this technology was evolved from there. So basically we had a Linux technology already available, and then we exposed. So Docker did a few projects basically on Linux platform, and then they why Linux? Because in production environment, Linux is the basically default standard, de facto standard. Right? Windows is slightly still not comfortable with Kubernetes and all that, but right normally we Linux is much more secured and it is easily available. Right, so that is what we do here, and then continuous integration, continuous delivery, CI/CD pipeline module. Right, we don't want to do manually, and then teams are working in silo culture. Test development team somewhere, testing team say, okay, when your development is ready, after 1 month, just call us. Right, and then that time we will prepare the test cases, and then we will take another 2 months, right? That means 1 month for development testing team, right? Or 2 months for development testing team take 1 month. That means 3 months, right? Because they do in serialization, sequential manner. Once you finish developer, then all they'll do the testing. No. So continuous integration, as soon as the development done, and we have synced this cycle into sprint by sprint, 2 week cycle only, right? Sprint cycle is mainly 2 to 3 weeks. So when the development is done, immediately testing team will also be doing the parallel testing, right? And their sprint cycle also they will achieve the milestone, right? And that is how we push the code from development to testing to pre-production to production, having this pipeline. We have laid down the pipeline having all the processes, and we'll drive the code source code from development to the production environment so that customer can get the code in production environment, right? So here we'll bring the CI/CD capabilities here. So in Docker we will learn those things, right? So CI/CD in short, but basically it's a continuous integration and continuous delivery. Continuous integration was already there. This we have introduced a new phase. I'll give you some use case stories about it. Don't worry, think it's going to be very interesting session, and we'll deep dive over here. And DevOps life cycle, that we heard the name of SDLC, software development life cycle, right? So we follow some steps, some patterns, some methodology, and we have its own life cycle, right? How the solution will be built, what are the parameters, what are the phases, what are the how the cycle is maintained. So same way here also we have a DevOps life cycle, as I said, CI/CD, right? Here from development to production, how we push. So following a DevOps life cycle, right? And then what is DevOps? So here we will learn, right? So earlier we have a virtual management technology. Virtualization we have been using for more than a decade, I believe. All right, or more than that might be, right? Now we are replacing the virtualization technology with a new platform we call containerization. So virtualization is replaced by containerization, or in simple word we say containers. All right, how that we will learn over here, virtualization versus containers, and then we will have a basic understanding what this Docker tool is going to bring in terms of architecture. So here we will understand architecture, and Docker also has an its own repository which we call registry, right? Why we are not saying here repository, why we are saying here as a registry, right? Why? Because here we have to register, right? Here we have to register, and then only we can say is basically a not a repository but a registry, right? You have to register, I have to register, every developer, every person who is going to work here has to register his code, his container, his application, whatever, right? So here we'll do registration so that we can authenticate, right? So here we don't say just repository, just come and put the things because I've created repository for you, put everything here. No, we have to register. So your ID will be created, and that is how we do versioning. Versioning capture all this metadata information, name, where, who, what, right? This information will be captured here. And then here we'll talk about the installation, right? So normally the de facto standard we do installation on Linux environment, right? CentOS or Ubuntu, but nowadays Docker as a desktop which goes with Windows, that is also available. Normally as a de facto we go with Linux, CentOS and Ubuntu, right? Now you must be wondering that you don't know about CentOS and Ubuntu, right? In Linux, don't worry about it. As a part of the course, we'll be teaching you Linux also, right? Even CentOS and Ubuntu, which is very very popular. Ubuntu is much more popular in terms of security and ease of use. It has introduced a lot of security. So here we will do all that thing. So here we'll talk about the installation because this is again an hands-on tool. Okay, so we'll set up the environment, do the installation, and Docker Hub. Docker Hub is basically a Docker Hub, like GitHub, Docker Hub, right? Realm Hub, right? All that hub means public repository, right? So here we have all Docker images. So Docker has more than millions of images. And that means every application you name it, we have it, right? Apache server, Nginx server, right? JBoss server, right? Any application, right? MySQL database server, MongoDB, right? Or Oracle database, right? Enterprise, Oracle Enterprise solution or a Fusion, right? Every application we have here in this repository we call Hub. It's basically public repository, and we'll start taking all our container images initially from here, and then we'll start creating our own images, and we'll push it to our private repository. We'll not use public repository but private repository, and we'll start pushing it so that whoever wants, customer wants, they can take it from there and spin up the application, right? So here we will see all that thing. And then Docker comes with its own CLI, command line, right? Docker command line. So all Docker command line, Docker commands begins with a Docker as a keyword, right? So Docker itself is a command. All right. So here we will see, and we have few hands-on session and some real-time assignments we will do so that you guys can get familiar. So here we will take from basic. Basic, once you build your fundamentals, we will go to advanced level, and that is the flow we always follow here. And then various Docker layers, right? Inbuilt layers, how the background things are handled by Docker, because here we are not doing any coding, not even single line of coding, right? But still we will be doing a lot of things here. We'll be building the image, right? By writing our own logics, right? We'll be dealing with networking by writing our own logic, but everything will be in a templatized manner, right? That I'll talk detail later. So here we'll see what are the nuances, what are the semantics of Docker in terms of layer, in terms of images, in terms of container, portable lightweight solution we call, because Docker brings portable lightweight solution. How, that we'll talk about here. And then Docker Advanced, as I said, here we do installation, build our basic knowledge by doing some hands-on and all that thing, and then we'll move ahead with an advanced thing. All right. So here we'll talk about Docker commit, right? Docker push, right? Push pull technique we involved here, and then we'll start building our own application like Jenkins build, right? Docker has its own inbuilt tool. We don't go outside Docker and go to Jenkins, right? Jenkins we can use. We have a Docker plugin there. We can integrate it, no problem. But Docker itself has an inbuilt build module, right? I can start code compilation and build my images. So Docker build will help me to build your real-time application into a container format, right? Container is a new landscape. We will building our application into a container. So all legacy application can be built into container. How, that we will learn here in the Docker build module. And then Docker volume is basically a storage, right? If my applications are built but they need a storage, I want to store the data, right? So for high availability, my application should not go outside Docker. Within Docker, that I can pass at the data using Docker volume, right? Bind volume is nothing but a shared folder. Sometimes we share information from the shared folder. We collect information from various sources as a folder we can do. And in production use cases, we'll see how the storage, how the Docker volumes can be used in production environment. Then networking, right? Here will you have, right? What would be the application IP address, right? How the subnet default gateway and all that can be considered, right? It's an automatic thing, but for a knowledge thing, we will take some use case and we'll create multiple network, right? So let's say I'm working for few customer, Oracle, IBM, Microsoft, three customer I'm handling, right? So to expose my application to IBM, right? How will I create a network, dedicated environment for IBM, dedicated environment for Oracle, dedicated environment for Microsoft or Google, right? And then we can push the application. So here we'll learn in networking. And then Docker Compose. Docker Compose is basically an automation. Here we'll bring the automation. So whatever we learn here, all manual things, and now we will go to advanced in Docker Compose. Docker Compose basically it gives an edge to microservices. So micro-based services will introduce here, and here we will see how we do integration as an automation layer, right? So here we will do integration with Docker using the automation layer, and then will practically learn the automation, right? I'll teach you how to learn the automation. So automation is again a key factor in Docker, and then we don't do any coding. It's just a YAML, right? YAML is yet another programming language or a markup language, yet another markup language, or yet end markup language. Though it's a language, but we are not going to do any programming here. It's all automated, and we will see just a templatized thing, right? Pass all the details configured in a template, and then deploy your microservices. So here we'll build the microservices, and then we'll deploy the microservices also, and we will see exactly a real-time environment using these microservices, right? So here we will see, and here as I said, here we will see how to create a single microservice or a multiple full microservice with having front end, back end, all that. So here we'll do few projects as an assignment, all right, and so that you can have a full hands-on experience, all right, so project experience. So here we will do, and finally Docker Swarm is a parallel tool of Kubernetes. So if you don't want to go to Kubernetes and you want to stick to Docker only, within Docker you want to create a cluster-based environment, your application are running so that it can be monitored, scaling, all that thing, we do Docker Swarm. But if I compare with Kubernetes, Docker Swarm is basically still not that matured. It is we do only for a simple level, right? Only at a simple to medium level only. For complex level or complex production environment, Docker Swarm is not appropriate. For that, we go to Kubernetes, right? But it's a parallel tool. So basic underneath technology of Docker Swarm and Kubernetes is same. So here we will see how to set up the cluster, right? Here we'll bring cluster and orchestration layer and how to do it, and then we create a multi-node cluster environment as a production environment. So here multiple machine, node means machines, so multiple machines, we'll create a collection of machine, a group of machines, that is what the cluster is, and then we'll have our own thing, and then we'll start deploying the applications here using microservices, all right? And here also we'll do a one full project here, right? And that would be automated, so full stack application will deploy it here, right? And then learn high availability capability, rolling updates, and all that thing we'll learn here. All right. So what else? So projects which we do. So full projects we do one project Java and Python. All right. So this project we'll do mandatory, and we'll see anything we can introduce. We can introduce it here. Lab setup and all that. Normally I do everything on AWS cloud. So if you have AWS account which is valid for 1 year, free subscription, right? So please go ahead and create your AWS account, which will be very used, right? So everything will be cloud. So that means we are learning automation, we are learning a Linux operating system, we are learning Kubernetes and Docker per se, that is also there, right? As that is the default thing. On top of it, we are also learning cloud, right? So if you know at least one cloud, right? AWS, here we will be exploring AWS cloud. If you know at least one cloud, that means you are more or less you are on DevOps side. You can directly venture into DevOps profile, right? So one cloud. So normally AWS, if you know, Azure cloud or Google cloud will be a lot more easier. Only a few terminals they will be saying differently, but underneath technology and architecture would remain same. All right. So here we will be doing everything on AWS, right? Which basically free tier. You need not to pay anything here. 1 GB, 1 GB RAM for Docker environment, right? And it's a free tier, no cost involved here. So that's the reason I go with AWS. And then, sorry. Linux operating system is the de facto. Here I'll teach you Linux, Ubuntu, CentOS, whatever, we'll do it. And your default profile, right? Your user default profile. Docker Swarm also will do on AWS cloud, right? With 1 GB, 1 GB, again, no cost will be involved. So when I create a cluster environment also, right, it will help me, right? And all that thing. Only for this Linux, when I set up on multi-node AWS thing, right, we'll be using no cost will be involved, right? Only for this single node, it will be involved a few penny, right? So basically it comes to around 5 USD. 5 USD, it will be around somewhere around 200 to 300 rupees. That is max I'm saying, because for me I'm using day and night. So for me it comes, for you it will be 200, 300 rupees it will charge only for Kubernetes master node, only very small, and that is very low cost, right? Monthly 100 to 200 rupees, which only for thing AWS charges, which we can manage. It's not a big deal. Only for this guy. Rest everything will be easy. So we'll be building everything on Amazon cloud. So that means you are getting many free courses on top of it. Docker and Kubernetes, right? You will be learning build tools, automation, YAML thing, YAML programming language, right? Which is basically a Golang, right? And even AWS cloud also, and Linux operating system. If you know, well and good. If you don't know, that's also not a problem. Right, on the fly, on the go, we will learn it. All right, guys. So that's all from my side, right? I think let me go to my PPT. If I missed anything, quickly let me check. So this we talk about it. Demand certificate, all that I will not talk. Prerequisite lab setup, which we already understood, which it will be purely AWS, right? And then we are here.